All right, so this is the washer method versus the shell method question. This is number 36, page 408 in your orange kind of Finney textbook there. And we want to compare the two methods. The washer method becomes, you have to switch the x and y's around, and everything becomes in terms of y when you're rotating around a vertical axis. So the shell method is much easier. So we'll start with the old washer method. You should know how to do this one. So first of all, a quick sketch here. We should have a parabola y equals x squared. So something looks like this. And we should have y equals 2 minus x. And so it's a negative slope at y equals 2. So it looks something like this.
Please come to the main door.
Okay. And so also x equals 0. So x equals 0 is your line there. So this is our region. Okay. And we're revolving this around the y-axis. So it's going this way, right? Okay. All right. So so we have to find out where they intersect. We're not given that in the question. So x squared equals 2 minus x. Where does that intersect? X squared plus x plus 2. Wait a minute. X squared equals 2 minus x. X squared plus x minus 2. So then multiply to negative 2, add to negative 1. So we have our intercepts here as what, x plus 2 and x minus 1. So that they intersect at negative 2 over here, which is outside of our region, and then here at positive 1. Okay. So x equals 1. That's gonna help us. All right, so the washer method, remember we have v equals, we have pi r squared, right? So the integral, and we have our r squared, okay? Now, when we do it this way, okay, the limits of integration are going to go from here, 0, okay, the washer method, because we have to do this, we have to split this region up. That's what makes this tricky. So we have two different regions. Did you guys catch that? Okay, just to double check. So I'm going to blow this diagram up a little bit, but because we have to use the horizontal washers there, oh golly, my computer's not quite catching up to me here. All right, so then that this intersection point is 1, and it's 1, 1, right? So we have to split this up into two different, this is a disk right here, and then this is another set of disks right here because we have different boundaries. There's one and there's the other. So the radius is going to change. So we have to go from 0 to 1, and then we have to go from 1 to 2. Okay, and then plus, so 1 to 2 of r squared. Now, I didn't put the dx dy here yet because what you have to understand is that we have to subtract our we have to subtract this function right here, the x squared minus 0 here. That's the outer function. So this has to be x squared. Now, the thing is, though, everything has to be in terms of y for a washer method this way. So this is y1, 0, and this is y2, right? We're going up. And so that means that this needs to be dy, and the r needs to be in terms of y as well. And so if you have y equals x squared, that's actually x equals square root of y. Okay? And so this graph right here, and I can't really make that bigger for you, but this graph right here is now square roots of y there, which looks a little funny. Okay, so that's going to be radius 1. So we want to root y in here. And then here, the this function here, the radius here for this washer, is going to be this 2 minus x. Okay, so y equals 2 minus x. This is going to have to be x equals 2 minus y. So this radius here is going to be 2 minus y. We're going to have to square that, and that's going to be dy.
You squared the first one too?
Yeah, this one has to be squared as well. Yeah, so we got pi r squared and then pi r squared. Okay, I'm going to draw this a little bigger because it seems a little small on the page. So v equals, okay, so we've got, so root y squared just turns into y, right? So that can be simplified. So we've got pi 0 to 1 of just y dy plus pi, and this here you may as well expand that out to be 4 minus 4y plus y squared dy. Then it's easier to integrate. So you can take the pi out of both if you want. It doesn't really matter. Factor it out there. So this is going to be 1/2 y squared taken from 0 to 1. And this one's going to be, so 4x, sorry, that's 4y, minus, that's going to go up to 2 divided by 2, so that's 2y squared, plus that 2 goes up to 3 over 3, so 1/3 y cubed, and that's going to go from 1 to 2. So this is going to be pi times just 1/2. 1/2 times 1 squared minus 1/2 0 squared. Over here, we're going to have 4 times 2 minus 2 times 2 squared plus 2 cubed over 3 minus 4 times 1. And again, I'm showing every step here so you can kind of see if you need to look back to this, plus 1 cubed over 3. Okay, so the volume is pi times, what's that, 1/2 minus 0, so that's 1/2 pi. And this one over here is pi times, okay, when we figure out all this, I guess let's take one more step. So 8 minus 2 times 4, that's 8 minus 8, plus 8 over 3, minus 4, minus 2, minus 1 over 9, or 1 over 3, it's 1 cubed over 3. So this should be just, that's gone. 4 minus 2 is 6. 8 over 3 minus 18. It should be just I think it's 1 pi over 3. So this is, volume is 1/2 pi plus 1/3 pi. Right? When you figure all that. And so we have the volume is 5 pi over 6 units cubed. All right, that's the washer method, and you can kind of see how we might have a bit of a need for something that's a little simpler than that. And that's where the shell method comes in. So we'll just kind of put that aside here now. We'll remember what this answer is, and I'll leave the, let's see if I can do this here. So let's do the shell method. I'll do it down here. I'll get rid of it over here. Okay, so this was the washer method set up. The shell method now is going to be quite a bit easier because, and I'll make this a little bit bigger now. So we're looking at this, and we're looking at vertical shells, right? Vertical, that we can stack this way. The difference, the height is going to be the difference between the two functions. We don't have to split anything up. So we've got now the volume is going to be 2 pi RH, right? So we've got 2 pi, we've got an integral, and we've got R and H, and we're okay to have this as dx. Because remember that the little differential, that's the width of the cylinders is the differential there, so dx. So if it's rotating this way, it's dx. All right, so the axis of symmetry is just the y-axis, so that makes things easy. If we're doing dx, we're going from 0 to 1 here, right? So 0 to 1 goes there. Our radius, the axis of rotation, is simply the y-axis, so it's x minus 0. So it's just x, the radius. And then the height is the difference between the two functions, and we do not have to, in this case, we don't have to switch them around, so we can just consider these two functions. So the upper function is going to be the 2 minus x function up here, and the lower function is going to be simply the x squared, so minus x squared dx. All right, it's a little simplification here. So this is going to be however way you want to do it, doesn't really matter. I'll put the highest degree first. So this is negative x cubed minus x squared plus 2x. And if you wanted to yank a negative out of there, you could, and put it out there. Doesn't really matter to me. Might be easier if you want to put the negative out front here. So then you can take this. This becomes a positive, that becomes a positive, that becomes a negative. If you have to do this by hand, if you have to do the integrating by hand, which you will have to, you will have technology for some things for sure, but if you have to do this by hand, it might be easier just to start with that, have fewer negatives there. So that's fine, we can take a negative pi out there. Okay, so then this is going to be, let's see where we are here. Okay, so this is going to be 1/4 x to the 4, I guess, plus 1/3 x cubed minus x squared. We're going to take that from 0 to 1. So negative 2 pi. It's going to be 1/4 plus 1/3 minus 1 minus, those are all zeros, right? All right, so we'll just simplify this a little bit and see if it comes to the same. All right. Okay, so if we put these all over 12, we got 3 over 12, 4 over 12, minus 12 over 12, and 7. So negative 5 over 12. Negatives cancel out. We've got 10 over 12 simplifying to 5 over 6, so that's going to be our 5 pi over 6 units cubed. All right, and arguably quite a bit easier than the washer method. You just have to do one set of integration. So the shell method, yes, is possible. We'll go over this tomorrow. It's possible to have your shells stacked horizontally, which we'll do tomorrow. But definitely if you have a vertical axis of symmetry or axis of rotation, then the shell method makes things, especially if you have just one function on top and one function on the bottom throughout. That makes it easy. Okay, any questions? No questions?